Well, you were online waiting, I'm assuming, and I can see
Yeah.
Ryan Darrington. I have Ryan Darrington rules to this day, Mr. Darrington. Thank you very much. I see Derek Williams there. Hi, Derek.
Hello, Mark.
Well, thanks. And Michele. Michele, I have one for you this morning or this afternoon, straight up. Kelly sent off a sample or an image to us and said, what is it? And I do have an answer, so I will give that.
Hi, Mark.
And Michele. So I will zoom in on this a little bit just to make it easier for people. I just got to find out how I zoom. I don't know that I can easily zoom in. So you can send them through to me as a large image if you want. I'll have to zoom this. Yeah, there we are. Can everyone see that fairly easily?
Yeah, that's pretty good.
Okay, so Kelly sent through this image and you wanted to know what it is. Well, let's see, McKelly, what you can tell me. I think it's hairy. What do you think?
Yeah, I agree.
What do you think it is?
It's I think it's a family or perhaps caterpillars.
Yeah, it's a caterpillar. And we can pick caterpillars. Caterpillars on the underside have these unusual things called prolegs. So they're not proper legs. So it has 6 legs. It has prolegs, 7 or more pairs of prolegs with these funny things called crotchets. We'll have a look at those tonight. So yes, this is definitely a Lepidoptera. And so that means hairy wing. Lepidoptera is hairy wing, scaled wing. So their wings of the adults have scales on them, quite beautiful. So the question is, how do I know whether this is a pest or not, and how do I go about finding out more? And I think that's one of the real important things for us when it comes to these, what we call macroorganisms, the bigger things. We ought to be able to go through the process of at least putting them into some sort of group and getting it down beyond just straight Lepidoptera. So I don't know whether anyone here has come across a thing called Google Lens. But Google Lens is one of my favorite innovations in technology. That's why all my images are in Google. I want to share everything I can with Google, everything I know in Google, so that Google knows about my images. And quick warning for those of you who decide to do nefarious things like grow a pot at home and post pictures of head on forums. Google is not the forum for you. And if you have to do it, strip your metadata out before you post it, because otherwise you'll have the police coming in knocking on your door. And of course, in the earlier days of digital images, that's exactly what the police were doing. So in this case, I simply took the image and I asked Google Images in Google Lens to tell me, or Google in Google Lens, to tell me what this might have been. So it gave me 5 or 6 different insects that it could be, or different groups of Lepidoptera that could be. But it ended up coming out that it was Anthella varia. And we'll talk about ways of doing more, but in particular, the 2 dots, the white dot on either side of its body and the hairiness and the color patterns of a orangey brown with long white extended hairs gives it a pretty unique situation. And we don't get to do a lot of Lepidoptera from the caterpillars. We've got a general absence of information in that regard. So where we can do it, it's great to do. And, you know, something like this is fairly unique in the way that it looks. So Google Lens was able to figure that out, give me some hints, 4 starts. It suggested a Lepidoptera first of all, but it clearly wasn't. And I did check Lepidoptera to see if there was one in Australia that looked like it. Then it said Anthella. And once I got to Anthella, then I was able to say, yep, that looks like Anthella. And I was able to confirm it by going to Butterfly House, which is a website run by a lepidopterist by the name of Don Herbenson Evans. And Don's a physicist who taught computer science and fell in love with taking photographs of Lepidoptera when he was at university at the Macleay collection, and ended up becoming somewhat of an authority on Lepidoptera. So his website is worthwhile going to if you want to know more about it. So last,
Mark, is there a common name for that woolly bear?
Yeah, I think there is, Peter, to answer that question poorly. But I would just use a Google search to find its common name, but the correct spelling will come up there in your visions. And I've just got to try and figure out how to get down now to a normal screen size. So yes, feel free to, when you send them through, to send them through as larger images. 2 or 3 megs or 1 meg is not a problem in an email nowadays, and we're pretty used to it. So how would I find that now, Peter? I would just go and do that exact search that we're just talking about. So Anthella, common name. By the way, it does eat leaves. There are a few caterpillars that are exceptions, and I can show you some of those if you want. Most caterpillars chew leaves. What else do you think they might chew?
Buds, flowers.
Buds and flowers, yeah, or tree parts, yep. So there's some wood-boring Lepidoptera, some fairly important wood-boring Lepidoptera. But
I suspect this is a wood borer though, because I find a lot of holes in the trees.
No, this is not a wood borer. This is a leaf
No.
chewing insect.
Okay.
So let's go and have a look at what Don Herbenson Evans has got to tell us about it. Anthella. And here we are, Lepidoptera butterfly house. This is Don's site. Common name, let's see. There will be one somewhere. So the caterpillars mainly seem to feed on the leaves of eucalyptus.
I think it was at the top, it was called Hairy Mary.
Hairy Mary, thank you. It is called a Hairy Mary. Now, there it is, Hairy Mary, thanks. So Hairy Mary is a common name for it. And you can see we match up with what you're talking about. So again, is that the only site? Well, Jaborski's got some information on it in his textbook, and we could look at that. So that would give us a little bit more information. But generally, these things don't have a huge amount of information available. If I remember, yes, it was Walker. The entomologist Walker in 1855 describes it. So the species has been known for quite a long period of time. So that's how that process is done. And again, one doesn't have to be a great entomologist. Just got to use the technology that we've got. But it does help to have some understanding. So let's have a look at.
Would you say that this is a pest that didn't necessarily need control, Mark?
No, this is a pest that almost will never need control. There are a few exceptions with pests. So most pests are there. The tree's got a lot of redundancy, and we don't need to worry about them until they get to an outbreak level. And for many of the insect pests, that doesn't happen most times. Every now and again, you'll get something go to huge levels. And unless they're ongoing pests. So let me go with some ongoing pests. Elm leaf beetle. If you're in Melbourne, Victoria, southern New South Wales, and even into Sydney now, you'll see elm leaf beetle. And it tends to be a moderate problem most of the time, and every now and again it gets quite a heavy population. White cedar moth is often a problem. It's often in high levels. I think it's Lepidoptera reducta. some years it'll attack the white cedar moth early in the season, and you'll get it stripping the leaves off in, midsummer. And in that sort of situation, it will need some thought as to whether you're going to control it if the white cedar is important. Other trees, other species that might be like that get higher levels. Some of our aphids can be problematic. But most of the diseases that we see that are unusual are just odd outbreaks. And there'll be things like the grey box that attacked or hit Sydney. It might be something like the stick insect attack of the Southern Highlands that stripped thousands of acres of trees from the stick insects getting out of filter. Cup moth is generally just, in a few specimens here and there, and every now and again you'll see them get to huge numbers. And in fact, if you remember from last time, we're talking about the red-shouldered beetle, and we said it gets out of filter sometimes. You can remember what red-shouldered beetle was.
Put a U in there, Mark.
Yeah, it doesn't like it if you spell wrong. Hymenoptera australis, and it goes from yay to nay in no time at all. So this is the little creature here.
Wasn't that a Pittosporum beetle?
Sorry?
Wasn't that a Pittosporum beetle?
No, Pittosporum beetle is very close. So this is Pittosporum beetle or Pittosporum leaf beetle. Wasn't a problem really for us until we started producing Pittosporum hedges. And so this is Pittosporum leaf beetle.
Oh, yeah, more markings. Yeah.
So a lot more red in the head. And let me just close that participants list down. A lot more red in the head and feeds on Pittosporum, whereas red-shouldered beetle is polyphagous. It feeds on lots of different things. Pittosporum leaf beetle will feed on other plants in the same family. So, for example, a common thing you'll see it on is Berseria. So Berseria is in the same family as Pittosporum. So leaf beetles are a common one. And I don't know whether Peter remembers this little creature here. No, it wasn't that one. Sorry, I thought it was. It's not. So yes, leaf-eating beetles, all identifiable by the same basic characteristics. This is Hymenoptera again. Number of antennae segments: 1, 2, 3, 4, 6, 7, 8, 9, 10 antennae segments, and we have Hymenoptera australis. So Chrysmilidae, leaf beetles, are all leaf-eating beetles, as far as I know. I don't think there's an exception. And they generally look either this sort of extended oval shape or they're a little bit more rounded in shape. So things like our tortoise beetle fits into that group. Let me see if I can find a tortoise beetle. No, see. No, what did I do wrong there?
OISC? No, OISC.
That's okay. I'll just do beetle. I'll find you one. So, again, if we look at these are larvae of the elm leaf beetle. Elm leaf beetle again is Chrysmilidae, or one of those leaf-eating beetles. This is a leaf-eating beetle. And we have problems. These things get brought in. Let me raise an issue. I think we did last block round, and I will raise it again. We still have not got any control yet or quarantine reporting on the East Coast for polyphagous shop beetle that's been introduced to Western Australia. I'm pretty sure I mentioned that last time we met. The fig leaf beetle is again Chrysmilidae.
So what's a typical control for these, Mark? Is it comfort or tablets in the soil, or?
Well, first rule for control is must follow the appropriate legislation. So if you're in New South Wales, you're somewhat limited. If you're in Victoria, you've got a lot more liberalities. If you're in South Australia and Tasmania, Western Australia, things are a little bit tighter around. So follow the labels. But yes, look, beetles are fairly susceptible to many insecticides. So the neonicotinoids, the spinosads, the pyrethroids, all these sort of new modern insecticides that have a very small risk associated with them. They've got an LD50, a mammalian LD50 that is often quite large. LD50 means lethal dose, and we're concerned about the oral lethal dose and the dermal lethal dose, and we're concerned about the impact that that has. Someone said, or Mick wanted to know, is another common name woolly bear? Quite possibly, Mick, for the previous caterpillar. Sorry, I only just saw your message then. The problem with common names is you can have any common name you like. So I think my daughter describes most of these as icky, and apparently that's meant to be a nice technical name. In other words, it's unpleasant. There's a Bacteria, and that's a Bacteria that's been completely stripped by Pittosporum leaf beetle. So,
Mark, what's the other pest of Pittosporum that's more of a sap-sucking pest? The one that causes the mottling of the leaf.
If you're talking about Pittosporum leaf miner on Pittosporum undulatum, would that be what you're talking about?
Yeah.
Yeah, okay. That's an interesting one. That's a fly. And we don't have too many fly larvae that cause problems. But that is one that, well, it doesn't cause a problem. It doesn't really affect the health, but it does affect the health of some things. So it can have a negative impact.
I don't see a Pittosporum here that isn't infested with these mottled leaves.
Well, send across an image and let's have a look and let's see whether we can confirm up anything on that basis. Now, a ladybird in comparison with a one of these other guys is different. One of the things is it's got a club on its antennae and fewer segments. So whilst I said some of the leaf-eating beetles have got more rounded bodies, that's not always the case. Here's Pittosporum, Pittosporum leaf beetle devastating one of the small dwarf Pittosporums being used in a hedge. And as soon as you start creating a hedge in a monoculture, you start to create problems. This is the larvae of it. So pretty distinct larvae in 3 different instars. Instar. Someone said to me after last block, what's an instar and what do you mean? Well, each of these grubs get to a certain size, and because they've got a chitin exoskeleton, it's a very thin one, but it's holding everything in, they have to shed them. And quite often we don't see them. So for example, when Peropsites calypso, the little green beetle that we get now on lily pillies, lily pilly leaf beetle. So there's a good example of a rounded one. Let me find that for you. Peropsites. Okay, so here we are. It's sort of more rounded shaped beetle. Quite small, if you see it against a ballpoint pen there. We know it's a beetle. It's got a folded wing and a elytra, hard forewings. And we can count the number of antenna segments: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, 11, including the base. So 10 segments and then the base segment. But when it sheds its skin, what happens to it? We don't see it. The answer is it eats it, it consumes it. And a lot of these chewing insects go through that process of chewing that previous shed skin. Interesting, other animals do the same thing too. For example, frogs, green tree frogs, or all the Latoria species when they shed their skin, they consume it. So it's not just things. And I rely on my authority on that one's Catherine Russo, who did some study on this particular beetle that unfortunately never got published, but hopefully one day might. Bob's family shots, you don't want them. So does that answer the Pittosporum one? To be sure on whether it's Pittosporum leaf blotch minor, let's get a picture of it and we can say. There is another beetle that, or an insect that affects Pittosporum. It is a beetle, and that's platypus. And I know that sounds wrong, but platypus is, in fact, it's the name of the genus. This is it here. It's a small weevil. It's an odd-looking weevil, downward facing. But if you look carefully, you can see the antenna is indeed geniculate. That is, it's bent and it's clubbed. It's just that it hasn't got a very pronounced rostrum. And they make these tiny small holes, and you can see that's the end of a key there. So it gives you an idea of the holes. And they introduce a fungus in with them, and that causes the rapid death and decline of the tree.
And this is on Pittosporum?
Yeah, they're on other trees as well, but this particular one, I don't know what the species is on Pittosporum. And you'll see it kill Pittosporum. The leaves will turn brown overnight. And so when you're looking at a Pittosporum that's looking a little bit sick, one of the things you want to look for is these tiny little pinholes. No, they're a little bit thicker than a standard pin, but not a lot. Maybe 1.5 paper clips, 2 paper clips thick, something like that. And they cause the rapid demise of the tree through vascular wilting. Okay. So leaf-eating beetles can be a problem. Did go back to insects. Can I go back to insects again? Forward one. And if you remember back to last class, we talked about some fairly important terms. We said some insects are homometabolous and some are holometabolous. Can you remember what they were? We said that they've got a complete or an incomplete metamorphosis. Anyone?
Lepidoptera, I believe they're complete metamorphosis.
So complete metamorphosis. What do we mean when we say complete metamorphosis?
They turn into almost a different insects, like from caterpillar to a butterfly, and incomplete metamorphosis will just, I think, increase in size.
Yeah, increase in size and change slightly. Pete, are you there? I've got a feeling we've dropped out here, Michele.
I can hear you.
Yeah, I can see Peter.
Yeah.
Yep, right. I just wasn't sure there for a moment. So great. Yes, so a complete and incomplete metamorphosis, we see some changes. Let me show you that on a Google page. And so we broke down our insects into that group. So complete metamorphosis is something like this, where we have an egg, a larval stage, some form of pupal stage. It could be all sorts of different ones. You know, here's another different stage. Then an adult form that is substantially different. So here's a beetle. And we saw those, you know, things that look like grubs, then things that look very different. And then we can have incomplete, an incomplete metamorphosis. You know, the young looks like the adult. The nymph looks like the grown-up form. Termites fit in that basis. And unfortunately, this is lice, same deal. The young look like the adult, they're just smaller. And so again, you can see this gradation. They do have some differences. One is the young don't have wings and the adults do. Now I've said that, having said that, there's a condition called neonate, which means the adult stays like a child. It never gets to a fully adult form, and that occurs in some insects in the order Hymenoptera, for example. So the adult always looks like the juvenile stage. It doesn't get wings. And when they don't get wings, we say they're apterous. Ptera meaning wing, so apterous, pteris essentially, apterous meaning they don't have wings. But there's a good one. There's a cockroach, and you can see each stage of the cockroach looks like a cockroach. It's only in the last stage that the winged buds, which don't appear very conspicuously earlier, except the previous instar, start to become really, really obvious. And so, indeed, that's the category that we're looking at. So, incomplete and complete metamorphosis. So, within our beetles, we also have Christmas beetles. They affect trees, and they affect trees in two ways. And they're in the scarab family, Scarabidae.
Mark, are you still there?
Beetles
There we go.
is that larvae will sometimes feed on leaves, but many larvae are below the ground. So things like Monoleptera australis is below the ground. So you don't get to see them until they come out, and they're our curl grubs. Let me just show you a couple of scarabs or Christmas beetles. Hopefully we'll get things right for me and get a couple right. Okay, this is a Christmas beetle. So things like these guys here. Those aren't. They're the stags. The stags are quite pretty, and stags are mostly feeding on dead material. But yeah, a lot of our Christmas beetles are called Christmas beetles because they're shiny ornaments. And this was a real problem in some of our rural areas, particularly in the New England. It was what was known as New England dieback. We'd clear out a lot of our trees, and then we'd have heavy populations of Christmas beetle. The larvae would fall to the ground, and whilst there wasn't a lot of tree roots to eat, there was a lot of pasture roots to eat. So they had lots of roots to eat, and they'd come out and every time in huge numbers and knock off most of the foliage of the trees in a matter of, again, a week or so, because there were very few trees. So things got out of kilter, and after a number of years of roots and foliage being chewed, the trees would succumb. And in fact, Peter, I think is something you get to see around Grafton. You can sometimes see fairly high levels of Christmas beetle coming around in that Christmas period, just stripping the trees to pieces. Again, for those of you in your areas, it'll depend. Sydney, we seldom see it, but you'll see it in places like Goulburn and Canberra. You can see high levels come out. So scarab beetles have that rounded shape to them like a Christmas beetle. There are some that are actually good guys, and so we've got to be careful not to put them all in that. The fiddle leaf, or the fiddle beetle. I'm trying to think of its. If I can, it might not come up. No, it doesn't come up. There is indeed a scarab beetle that's a good flower pollinator. So we've got to think of things as being more than just good or bad per se. And I think that goes back to that question earlier. How do you manage these things? In most cases, if you don't need to treat, then not treating is a smart move. When you do need to treat, you need to treat in accordance to the label, and you want to try and limit your off-target damage. That is the damage to things that might be beneficial. And You also need to recognize natural predators, because a lot of insects are attacked by other insects. We need to know what they are, and we'll certainly have a look at some of those in time. But if I can, I'll find you one. Okay, so here's one. This is a lovely beetle that just wants to break the rules. This is a nice scale-eating beetle. It's native to Australia, and it eats on scale on casuarina. So when casuarina scale levels start to get high, these guys come in and pretty quickly bring the population back under control. So we want to see things like that happening. So last time round, we were looking at Longicorn, and I'm pretty sure we discussed Agrianomi and Phoracantha. And Ryan Darrington, hopefully you'll turn your mic on and say hi. But now all the tastes throughout Australia have a requirement that you must see the insect to use it in your disease profiles, because Ryan was smart enough to figure out that you could do just one genera and do a whole pile of them. So yeah, this is one of those flower pollinating scarab beetles. So we've got to look at the good and the bad. And in fact, lots of times in botany and entomology where they interact, we get these really unique things where the pollinator, in at least one of its stages, also feeds on the plant. A good example of it's the tobacco hawk moth in the US that pollinates the tobacco. The larvae also eats on the leaf. And that's even a more fascinating story, is when the population gets too high of the larvae, the tobacco has an alternate flower form. It's completely different and can't be pollinated by the hawk moth. And that's just to stop the hawk moth population going too high and affecting the tobacco. Most insects are killed by tobacco, like most insects are killed by neem or by azeractin and the insects in that, the white cedar. But there are things that are adapted to deal with it, and tobacco hawk moth can eat tobacco without significant side effects. Nicotine, of course, is highly toxic to many insects, and it's that derivative that we've developed, the neonicotinoids, means they're like all the new nicotines, are modified nicotines, or are copied off the nicotine molecule and tweaked, so they're not a problem for mammals. They are a problem for aquatics, and they are a problem for off targets. Excuse me whilst I wet my palate again. So yes, not all of these guys are bad. Here's another good one. I'm not sure whether we discussed it last time, but this is the mealybug destroyer. Looks like a mealybug. When you turn it over, it's clearly a beetle larvae, and it's really important in controlling mealybug. And it's often sprayed inadvertently as a pest rather than being left alone. So we definitely do want to make sure we get our diagnosis right. And so after you think you've got it right, it really does simply mean going back, doing a little bit of research on the internet, looking at some images, making sure that you're getting things pretty close to accurate before you going crazy. So now, yep.
Sorry to interrupt. I just was hoping that at some point, even if it's not today, you could help us out on, give us direction how we could identify an insect. So we come across something that we've never seen before. What sort of features we got to look for, at least to direct us towards the genus? Doesn't have to be the exact species, but at least down to the genus.
Let's get to the order. And once we got to the order, getting to the genus is a little easier.
Okay.
And a lot of it's just hard work, unfortunately. Kelly.
Yeah.
Google Lens is a great way of starting now because it'll do some of that work for you. But I was going to show you, and sorry.
Mark, would the chart that you put up, that we put up into the Dropbox of the orders, that would be of assistance?
It's got some key features in it, but all of these things are, I mean, this is a huge thing. Remember, there are more species of beetle than there are of any other order in the world by orders of magnitude. So, you know, when you start saying, can I get down to getting down to orders, to beetles is a first start. And fortunately, that is often enough to start doing something or start thinking about something.
Some of these insects have not been described yet, so it's not really possible.
Huge numbers. You start talking about wasps. I watched a doco or a short educational video by the head of CSRO, who's a hymenopterist, a wasp expert. And he was saying that by the time he retires, and he's younger than I am, he was hoping that he would have had at least 5% of the wasps in Australia identified and named. So that gives you an idea. Now, wasps, a little bit more difficult because they're smaller and often hard to observe than beetles. But yeah, you can go out and find a new insect. I think I mentioned, you know, leave your light on for a couple of nights and you'll certainly collect something. Go out with a beat sheet over a few days and you'll find something. I've found one new species of scale already, and that's just by samples that come into class and samples that I've taken into class and saying, what the hell is this? I know that a second one was found in Sydney not so long ago, a species of scale on palm trees that still hasn't been named. So there's lots of insects that we don't get, but if I can get you down to order, Michele, then from order down to families is a little easier. And there's some good tips that I will give you, absolutely, and we'll actually go over those today.
Thank you.
Start looking at some of those resources that you can use. So I said to you, we want to know whether it's got crotchets or not. So let's try caterpillar. And Google's using an algorithm to find things. So he thinks this is a caterpillar, and clearly it's not. Whereas this is a caterpillar, and this is a caterpillar, and this is a caterpillar. So let's do these three for you, Michele. So here's a caterpillar with a really unusual marking on it, 2 red dots. And it's on a tree that you won't see very often. This is on Ignoregulus. They're Ignoregulus buds. But we've got some characteristics that make that fairly obvious. First of all, it's a caterpillar. If we turn it upside down, we could see that. So let's see what we need to know about the upside down stage. Let's see if I can find a shot that will tell us. Okay, here are the 3 legs. 1, 2, 3 legs. Can you see the 3 legs? Everyone?
Yeah.
1, 2, 3. Yeah. 3 legs each side. Okay, so this is the head, the thorax. All of this is the abdomen. And here we've got these funny little, what we're calling prolegs. Okay, they're not proper legs. They're like legs. And they've got these things called crotchets on it. And if I zoom in on this image again, I should be able to zoom in. Oops. Didn't like that. I don't know what I did wrong. Yep, zoom. Okay. The crotchets are down here. These are the little pink bits down there, little hooks. I'll find you a better shot of some crotchets. So crotchets are what this caterpillar is holding on with here. I need a big wood moth. Wood moths are great. massive big. Let's see, CRO. Oh, there we are. How's that for you, Michele? So this is a pro leg, and these little hooks, can you see the hooks? All of these are little hooks. And so it's not a proper leg, doesn't have any articulation, it doesn't have any moving parts, but it's got these tiny little hooks. And that's why caterpillars, when you get them on you, hold on to you very well. The thing that you would most confuse a caterpillar with is either a beetle larvae, has no crotchets. So let's go back and see where Google makes a mistake with its algorithm. Okay, Google says it thinks this is a caterpillar, but it's not. It's a larvae, absolutely, but it's 1, 2, 3 pairs of legs and nothing else underneath. So it's definitely not a caterpillar. Caterpillars have got prolegs. The other one that we can confuse it with are these guys here. These are sawfly larvae. And they sometimes can have obvious prolegs, other times they're not so obvious, but their prolegs never have crotchets, so never have the little hooks. So with a little loop, you can pretty well get into Lepidoptera as an order fairly quickly. So hopefully that helps you with Lepidoptera. Once you're in that Lepidoptera, then it becomes difficult. So 2 orange dots. If I went and did a Google search for caterpillar, 2 orange dots. I'm going to have to start seeing what I can find in images. Yeah, I'll help it with spell things correctly. And so I can go around and start saying, wow, that's getting pretty close. In fact, that's identical. And it's one of the brown-tailed moths or Euproctus. It's not a Euproctus edwardsii, but it is Euproctus all the same. Euproctus, if you remember, we said, oh, we haven't said, Euproctus edwardsii. We'll get to that later on. So that's how hard it was to identify it. So what are the most common features we can find? And so what you really need to do to start identifying these things quickly is build up some knowledge about insects, build up some knowledge about things to look for. And that's why we're here over the next, 6 or 12 months. We'll be looking at all sorts of diseases to build up that base knowledge. So when you say, what is it? You can figure it out. So hopefully that gives you an example of the processes that are involved. So this is indeed Lepidoptera. And don't worry about remembering, just remember it's the itchy caterpillar or the brown-tailed moth, a brown-tailed mistletoe moth, horribly itchy caterpillar. So, and I guess that covers the caterpillar side. This guy looks like a caterpillar, but clearly isn't. Why isn't it?
No prolegs. Doesn't have prolegs.
No prolegs, yeah. What is it, Peter?
Is there a termite?
It's a queen termite, yeah. And they are amazing. They're just, the reason she looks like this is her abdomen has been stretched. When you give birth to 32 million kids, you would look the same too. Okay, so that's all that she is doing. Some caterpillars do this sort of stuff and become leaf miners. So leaf miners make the identification more difficult. You actually need to then go in and extricate them out, cut the blister and remove them. But a good one that you'll have in most places of Australia is oak leaf miner. Oak leaf miner is a perfectly good one. So whilst we're talking about caterpillars, let's finish off with some more on Lepidoptera. You've probably all noticed that caterpillars change completely. They can become one of two things. Does anyone know?
Moth or butterfly?
Moth or butterfly, yeah. So, but what's the difference between a moth and what's the difference between a butterfly?
Moths have feathery antenna and butterflies have a clubbed antenna.
Moths have a feathery antenna and butterflies have a clubbed antennae. Butterflies will often fly at night. Sorry, moths will often fly at night. Butterflies all fly during the day. So let's have a look at a clubbed antenna if we can. So this antenna is what we call clubbed. So this is a butterfly. If I go to, let's have a look at a couple more clubs. We can. These are all moths. Yep, okay, here's a good. So again, you can see the clubbing of the antennae. And when they're sitting, butterflies will often sit with their wings together. So now I want to try and find you a good moth. So this, not a good example of a moth and its hairiness. Find you a good example of one. Okay, hawk moth, still not. They're not the best antennae. What are antennae used for? Can you remember?
Sensory.
Smelling stuff.
Smelling, yeah, they're the
Yeah,
smelling.
pick up pheromones for the female.
But pheromones for the female is really important. So if you were trying to tell the sex of a insect, and that's a really silly thing to think about, but it is useful on occasions. If you want to tell the sex of a female or a male, the one that's got the hairier or the bigger receptive area. So a male moth has bigger surface area, so it's got a hairier set of antennae than a female moth. Female moths have less conspicuous antennae. And for all the images I've got, you'd think that I'd have something that was really nicely hairy, but I don't. A gypsy moth would be a good example of a moth with a, I can do a gypsy moth. With a really good hairy antennae. The males, and I'll get into trouble for it, so I might as well do it now. Males can smell a female 20 plus kilometers away when it comes to a gypsy moth. And when you think about that, that's pretty amazing. So here's a moth with a really good antennae. So nice male, good receptor. So hopefully that helps. Moths have their wings down and fly mostly at night. So there's the difference between those two. So again, how do you know whether it's a moth or a butterfly from the larvae?
I don't know.
But grow them on. Butterflies have a very different pupal form than moths. Moths spin cocoons, whilst butterflies have a chrysalis. Now you're going to ask me to spell chrysalis, and that's going to be almost impossible. Chrysalis.
Here it is.
So this is a chrysalis. So here's chrysalis for our, we call a wanderer. The US calls a monarch butterfly. Does everyone know about the monarch population, how it goes, what it does?
Yeah, it's pretty amazing the way it gets around in the North America.
So yeah, it does a 2-year cycle. It comes back and does what they call a Methuselah generation. And the Methuselah generation lives for huge amounts of time, and they accumulate in places in Mexico and a few spots in America. And a friend of mine described it as you get there and there's so many butterflies, you're seeing branches break off So I'll just show you so that if you haven't seen it, you go and at least do some research on it. Monarch butterfly, and that's zoomed in, but this gives you an idea of what the populations get like. Just whilst that still opens up, just in the millions and millions and millions and millions and billions. So one of the to-do things I think in life is to head down to Mexico and see the swarms before we screw it up. The great news is it was only just published about a month ago. Our monarch numbers have been increasing recently, which is an absolute amazement. Let me see if I can show you. No, it's as big as it'll let me open. But it gives you an idea of the density of the butterflies. And the fact that it has these 2 cycles with what's called the Methuselah generation makes it even more amazing. So butterflies, moths have some other characteristics. Moths have a highly reduced feeding mouth part. So most moths don't continue to feed. They have a very short life cycle as an adult. Their primary goal then is to go out and reproduce. Some, let's see if I can get a good shot for you. No, I'm not going to get a good shot out of that, unfortunately. Some, so most butterflies have a thing called a proboscis, and they have a curled proboscis that allows them to feed on nectar. So moth, let me show you moth mouth part. I think this is right. No, it's not. Moth. As an adult, here's another distinct difference. So butterflies usually have this rolled up mouth part, whereas moths do not have it. So very altered mouth part. And now again, there's variations. That here's a moth that does have a proboscis, but most do not. Most are shorter lived. What else do you want to know about these guys? Some are, and I don't know whether we've had the word yet, voltine, a number of generations in a year. We can have univoltine, multivoltines. And we said some are boring insects. This is one. This is a xylorected wood moth. And they're common on fruit trees, and this is from a eucalyptus, a native species. We've got some that are introduced, but we also have the giant wood moth. And here's one here. This is this one's from eucalyptus. I'm just trying to think of its name. Maybe someone will remember and give me a hint on it. Head's gone dead on it. Indoxula. So it's Indoxula. This one here, very different. This is off a widgety, the widgety tree, and that's in the same group, but a different species altogether. So keep in mind that some wood moths are boring. The other lot that are interesting is, and I'll see if I can find it, scale-eating caterpillars. No, can't find it at the top. But there are scale-eating caterpillars native to mainland Australia, and they're important in controlling scale populations. So again, we've got to be careful when we say I want to go out and eradicate things. Sometimes we end up with things that we don't expect. Here's a common one on blue gums. This is autumn gum moth. You can pick it up by these two yellow lime green spots on its back. It'll also feed on some other species of Myrtaceae. And it's called autumn gum moth because it's predominantly seen in larval stage during the autumn period. So I think that's a pretty good cover of Lepidoptera. Oh no, we haven't discussed these guys. The ones that live in cases. Case moths are a really unusual exception to the rule. The female never flies. She's apterous. That's that word again for us, apterous. She comes out and never flies. And because she doesn't fly, the larvae have to get around somehow. And there's got to be a way or a mechanism for them to disperse themselves. So the way they do it is they spin a very small length of silk when they're very young, just first hatched, and they balloon. They actually, there's enough friction with the wind that they can float, and they float away to a new host tree. The dilemma becomes if during the launching season you have a very still period, or you've got a lot of other plant material hedging buildings around that inhibit the spread. And when that happens, you end up with huge numbers of case moths on the one tree. And so you can fairly rapidly end up with a tree being defoliated by case moths. Case moths, Lepidoptera in general, there's a really great biological control. And that biological control is a organism called Bacillus thuringiensis, or BT. It's sold as dipel in Australia, the particular strain. And dipel needs to be applied to the foliage evenly so that the caterpillar there, when it's chewing the leaves, it eats the spore and is killed. And it needs to be applied before they get to the end of their third instar. So they need to eat it before their third instar. The fourth and fifth instar, it has very little impact. So again, that just helps you keep in mind about case moths. There are a whole pile of them, and they're easily identified based on their casing, the shape of the casing and their habit. This one here, this is a gum leaf skeletonizer. It strips the lamina, the surface off the lamina, leaving the leaves behind, the rest of the leaf behind, and it's identifiable by these head casings that are left behind, and again these urticating or irritating hairs. That's not it there, and that's not it there. Close it out. I said boring ones. I don't know whether that's a boring one there or whether it's okay, that's not a caterpillar. Why not?
There's no legs.
No prolegs. It's got very reduced legs. This is a longicorn, and you can see the longicorn larvae looks quite different to a caterpillar. There's not a lot of similarities. I said earlier on, some of these guys can sometimes look like caterpillars. And this is, again, one of those sawfly larvae. And we looked at the underside, we'd see that it actually has no crotchets on the prolegs. And another distinct characteristic, wasps often have these pointed terminal components to the abdomen, and sawflies fit into that category. It's fairly pointed when you look at it. Wow, don't do that. So you can see here, it's pointed at the tail end. And because the crotchets aren't present, these prolegs here are nowhere near as conspicuous as they are, and nowhere as effective at holding on. So they're often missed. But that's a sawfly larvae. One of the things that is useful for you to have as a arborist is some form of way of photographing and magnifying The new mobile phones do a fairly good job, but they're not brilliant. Oh, I wish I'd stop doing that. They're not brilliant. Again, you can see these prolegs, so more like just stubs, rather than having some form of grabbing devices sitting out, so they don't hold on well. So Sawf larvae shouldn't be confused. Again, looks a little bit like a caterpillar, but this is a hoverfly larvae, so very different, no prolegs. Again, sawfly larvae, 6 legs. And by the way, whilst we're at the sawfly larvae, they're Hymenoptera. Hymen meaning thin. So these guys have very thin, nice, clear wings. And these are regurgitating out waste products from digestion. The waste product here is eucalyptus oil, essentially. So who here, has anyone played with eucalyptus oil? Anyone ever done anything dumb like me? I can tell you, Peter, do not put a couple of capfuls of eucalyptus oil into a bath and have a bath thinking that it's nice and soothing. It's nice and burning. Very unpleasant, very painful. So yeah, good. There's a point to which this is a product that is a part of its defense system, and it's not a big issue. They're not Spitfires. They don't spray it everywhere. They're just generally fine creatures. Leave them alone and you'll have no issues with them. I think that covers Lepidoptera fairly well. I mean, there's a lot more there that we can go through. Any questions for anyone on Lepidoptera before we look at the Hymenoptera? Any questions in the chat? Yeah, there's a question in the chat that I've missed.
There's a comment.
Someone said they found iNaturalist really handy for identifying. That's Amy. In helping identify insects. Amy, do you want to come on and have a quick chat with us? Turn your mic on. So some of the other ones that are useful, and it's an odd collection, but Brisbane Insects is a website set up by an amateur entomologist. And whilst you may not get all the answers there, you can start seeing things fit into pictures. Now, they're all pictures, so he's not an entomologist wanting to go out and describe things in complex things. He wants to look at trying to get things visually described. So he's a photographer. So we looked at aphids and scale insects, for example. You know, he's got things broken down to groups, and we've been having a look at some of these guys around. And this one you've seen, and a few of my pictures coming up. And this is a giant mealybug. So just simply by looking at large numbers of pictures. So Michele, I'm going to let you pick an insect that you can't identify as I scroll through here. You just tell me when you want to stop and we'll go through and we'll see whether we can identify it.
Stop. That's the red scale. Just go up a little bit. I mean, yeah. Okay.
So you already said you know that it's a scale. So that's already got it way, way down. One of the things we can do is if you've got a photograph, you can do a reverse image search. So even if you don't want to use Google Lens, you can, depending on the search engine you're using, I've got two set up. So Google reverse image search and see what it can come up with. Now you've got to be careful. Sometimes you get things that come up that are inappropriate. In this case, we've got nothing that's come up at all that's similar. But we do know that it's a scale insect. wonder why it's
Actually,
called parasitism. And it's got a hard surface to it. It would be useful for us to know something else. What else would it be useful for us to know? We'll find our image again.
Host plan.
Host plant would make a huge difference for us. So let's just assume, I'm going to guess camellia.
Hmm.
And then go to image search. Can we find anything that looks at all similar?
Maybe that yeah.
Yeah, again, without having all the information in front of us, it is possible that this is what we're looking at. So now, what we want to make sure of, if we're going to go to that stage, is we can do two things here. We can either go back to our general search engine, and I apologize if you don't use Google and you need to use something else, that's fine. But one of the things you can do is use your tools on it to try and limit your information down. So by telling it that I'm using googleinaustralia.com.au, it will now give me the opportunity and tools to specify my country. And that is, I want to only have it for Australia. So I can search Australian sites only. Or I can turn around and put my detail into it. So is this scale in Australia? And boy, can you believe it is actually in Australia. But doesn't look like it's very well located. So in fact, you're absolutely right, Michele. If I jump to the conclusion and said that I found it without testing it, without putting it through the process of saying, has this been described? Is it here now? There's a problem with that as well. And the problem with that comes, I'm sitting there and I think I've got it identified, and I say, it's not an Australian. In fact, I marked a student's assignment once, and if he ever hears this, I apologize. He identified a fungus. Unfortunately, he took an image off the internet to do it, which was a mistake. But I concluded that it wasn't in Australia. And then about 7 or 8 years later, I found it. And indeed, there have been about a dozen odd reported occurrences of that particular fungus in Australia. It's exotic, it's introduced. So the maize gill fungus is a brown rot on conifers, and you can find it in Melbourne and in Adelaide Botanic Gardens. In fact, is where we know it was definitely introduced. So again, very important that you consider the possibility, am I dealing with an exotic disease? That is, have I got something that I should be reporting? Have I got something that needs to be addressed? And as our knowledge of plants and diseases improves, our ability to pick those up increases. So I've reported on 4 occasions an exotic infestation back to our reporting agency because it's been introduced to the country. And most of them, fortunately, don't cause big problems, but we certainly need to be aware that they can. So yes, did I get it perfectly right? No, I know I've got a scale insect. I know that I'm half the way there, and it's probably not pulvinaria as the thing. Cottony camellia scale does not appear to be in Australia, but we'll check to see if it anymore. So a good search process. Well, it says it's present. So there we are. It is present. So that's probably what it is then, Michele.
Mhm.
Mark, your previous photo had a red dot in Adelaide.
Yeah, odd that it's only been reported once. So this is an amateur collected, oops, where do we go with it? This is an amateur and semi-professional collected information where they record where things are found. And obviously it's just something that hasn't caught the interest of people observing and recording. You'll find other things have got huge numbers of references to it. So yes, Adelaide is where the only person who's recorded it down has recorded it, but by the looks of things, having it here and having it in those two states is a high probability. So do you want to try another one, Michele? Because that was probably a little bit easier than we want.
Stop on the right. That's sort of maybe wasp thing looking.
Here,
White. No, just the next one to the right.
here.
Where's the? I can't. Yeah. That's the one. That's the one.
Oh, okay. So, great. We need to know some things again. First of all, we know one thing about this already. What do we know about it?
Has wings?
Has wings, but are they properly formed wings?
No, they're not.
So we know something about it. What do we know?
It's a pupa stage.
It is indeed a larval stage. Sorry, a pupal stage, not a pupal stage, a nymph stage. Nymph stage. So larval stage means it doesn't look like the adult. This does. And here's another shot of the same creature. And this is a great example. This is an almost naked psyllid. Now, I can identify it as a psyllid because psyllids look, again, fairly similar. So this is this process of getting familiar. Let me try PSYLLID. So psyllids have these fairly similar looking characteristics. Look, here's another one, another one. Okay, so it's just getting used to those bits. More psyllids, more psyllids. They look like something like little cicadas. So knowing that it's a psyllid, knowing that it's nymph means that we're already in a limited group. If we turned it around on the underside and looked, we'd see that it had a proboscis or a modified feeding mouth part. And so that would automatically mean that we know that it's Hymenoptera. And so we could get to a Hymenoptera fairly quickly. From Hymenoptera, it starts to get a lot harder. And that's because a lot of these things have not yet been identified again. So for example, grey box psyllid we know is Cardiospina spur, but spur is what it will probably be for the next 20 years. And to give you an idea, that's the sort of damage done by Cardiospina spur. All those trees are now dead. Just went through and
Grey box.
decimated. Killed over 2 attacks. It killed over 20,000 trees in the metropolitan Sydney area. Those attacks were over 4 or 5 years, but it still gives you an idea. So lots of different psyllids out there, huge different responses. This particular one, again, there's an expert, Gary Walker, and another Walker, goodness knows why. Gary's a brilliant entomologist, and he's the guy that we really need on to describe these when we can't. But if I said psyllid up in a Google search, and I'm pretty sure that's from an Angophora. So knowing that it's psyllids halfway there, so if I start searching, I may be able to find an image that will give me some hope that it's there. The other thing is I can start going to some of the textbooks now. So there is a 2-volume compendium on insects by CSIRO. I'll find that for you now. Book. It's not a field guide, it's a horrible text. If you ask me next time round, I'll find it for you. A good text generally is this. Let's see, I don't know, the cover's shiny. Let me take the cover off if I can. Yeah. See it. No, it's, oh, hang on, it's because I got blur on. How do I turn blur off? Don't know. Okay, it's called Pest Diseases, Ailments and Allies of Australian Plants. It's by Elliott and Jones, Roger Elliott and David Jones. It's, I think, the 4th or the 5th edition, and it is brilliant. It's got lots and lots of images in it, just chock-a-block full, lots of information about what they are. Be cautious in terms of any treatments that are discussed, just to make sure that they are up to date with the chemicals that are available. So, Insects of Australia, there's CSIRO. Yeah, there's the other one I was talking about. It's a nice early edition, but it's got lots of information. So going through psyllids and looking for information about it may be useful. So the last group I think we need to go through are the wasps. And wasps fit into that group of good and bad together again. Michele, does that give you some hints as to how to get started? Sorry, I should have asked.
Yes, yes, it does.
Do I get to stages where I get confused and I've got no idea? The answer is regularly. And so one of the things that's important with a lot of these things is growing them on. Growing them on means Chinese food containers, what we call click boxes, or boxes that you can lock up securely with tiny little holes in them, sometimes with no holes in them. And in fact, I would say probably 10 to 20% of the time I've got to, when I'm looking at something new, I've got to grow it on to get an idea of what I might be looking at, because I've not seen it before. In terms of a larvae, sometimes they're just very nondescript, something like this caterpillar here, it's just nondescript. I'm not going to find out what it is. So the only way I'm going to find out what it is to put it in a container and get it to adult stage. At adult stage, I'll be able to find out what it is. It's a lot easier identifying adult larvae. I once asked Don Hermanson Evans what percentage of caterpillars allow you to identify the adult, and he estimated probably only 5%. So, you know, it could be as high as 10 or 15%, but in most cases, we're going to have troubles identifying again. It's a looper caterpillar, so it's, you know, the looper caterpillars, they make a loop when they move. They've only got 2 pairs of prolegs at the rear, and they make these big movements. Hans Christian Andersen called them inchworms. These guys all fit into one family. So again, knowing something about their movement, they all fit into, I think it's Geometridae. Let me just see if I can check up on that rather than leading you astray. Inchworm. Yeah, so this is the inchworm type movement where we take nice big loops. So we've got 4 pro legs at the rear plus 6 at the front. And I've got a feeling they're in that order Geometridae, but let me just see. Sorry. My spelling is hopeless, as you've probably gathered. Yeah. They are. Belong to the order Geometridae. That's a good guess. So, you know, you might get a little bit of information from something like that, but oftentimes it just sit there and grow it on, grow it on, grow it on. I can't tell you how great the Google Images app. You need it on your phone to do it, in case you're wondering, or if you've got a Google device. But it's in the Google app itself. And in the Google app, you go to search. Let me find it for you. So there's a whole pile of stuff on how to use it. Our videos are the same. Just download it onto your device and run it. But here's a quick example of it being used for plant material. You can use it for
Google Lens came out in 2017,
all sorts of things.
and it's a way of using the camera on your phone to understand a lot more in your surroundings.
See if I can jump it ahead.
I haven't
Okay.
Hymenoptera elegans. Hymenoptera elegans.
So he's used it
Well, I
to figure
did
out
confirm with the
Hymenoptera.
receptionist that is the exact name for the plant. I just don't know how to pronounce it. Now, say you're walking down the street or you're in a subway and you just see something you really like, whether it's a shirt, shoes, a carpet, a sofa, whatever, really. Google Lens can help you find out what that is. All you need to do is
Oops.
camera, open up Google Lens and point it at, for example, the pink sneakers that I'm wearing from Nike. And you'll see these little circles popping up. All you need to do is tap on them and now you'll get a feed of similar looking products. And there we go. That's exactly the pair that I'm wearing right now. So it definitely works and is very accurate. But of course, you might have to sift through a few other options. And this works for more than, you know, clothing. You can also do it for.
So that gives you an idea. You can use it for everything. To the point that it gets scary. The other thing is if you use Google Photos on your computer, I use it to share everything with Google. So that's what I'm looking at now. I'm not looking at my photo library on the computer. I'm looking at my photo library on Google's information. First of all, I help share it with that information. And the second advantage of it is it can do things that I can't do, like recognize faces. So I've got to the stage there where we were sitting at the dining table having a discussion about a photograph that we'd found. We said, you know, a baby photograph. Is it Ethan? Is it Jessica? None of us could agree. So we simply asked Google, and Google was able to tell us with absolute certainty that it was indeed Ethan. And I'll show you how good it is with faces. It's only in your own library. But if I went to someone like Kobe, it's good at picking up Kobe, but it's also good at picking up Kobe when he was really young. And I wouldn't even have a hope in hell of identifying him as a child. And it doesn't just get to that stage, it gets to the absolute baby stage. So, you know, that to me just looks like a baby. The fact that my daughter's holding it and it's blue-eyed means that it has to be Kobe, but it's certainly not something that I could do without Google assisting. So, and it can do that for pretty well anyone. If you can see the whole face, you can figure it out, but it's got to be in your collection to start off with. So unfortunately, it won't let you search and stalk other people yet. I'm waiting for that option to come out where you can take a photograph of someone. And in fact, some software like that already exists. I mean, you know, facial recognition software is amazing. Just Google is more sensitive about how it uses it. Another advantage of Google Photos, if you haven't started to use it, if you share your images with Google Photos and you're nice enough to share your location with it, which I now do because I'm not worried about, you know, anything stupid. I can hit on the information panel, and there it is. It is Euproctus, and it shows you exactly where I was, plus or minus 20 meters when I took the photograph. So it allows you to go back and find things. I use it now for all my tree photographs in schools because it allows me to sit there and say, I can pretty well plot it. And indeed, the ignoregulus is pretty close to there. So give or take a meter or so. Is that a useful facility to have? So I'll encourage you to think about, so it's just making geo tracking available on your images. So again, if you're doing silly things or if you want a lot of privacy, please don't do that. But if you're happy enough, then it is, the Google photo process is great. The other thing, if you do ever get to the stage where you've got someone else working with you, and Peter, I know you're in this situation, I take photographs, for example, of my paperwork, of notes that I've taken when I'm on site. They're in the office within minutes or so, and someone can be working on it straight away. The other day, I had a young lass say to me, I finally figured out Google Photos. You've given a description of the trees, and from where you've plotted them on the plan with an X and given the number, I've gone and found the photographs that I think most suitably match, so you don't have to do as much work. So again, we are getting there. So wasps, I wanted just to finish a few last things off on wasps. Wasps are mostly good guys. Some of them are boring insects. By the way, this is not a wasp. Flattened body, like that. Does anyone know what this guy is? This is a hoverfly, and hoverflies are insectivores. So these are good guys. So again, just being able to recognize our good guys, fairly important in our process. So some wasps are boring. None of them are really boring. I mean, they're phenomenal organisms. But almost all wasps are good guys. There are some wasp imitators that are bad, but sawflies are probably the group of wasps that are most problematic. One of the sawfly wasps is the leaf blister sawfly. So it's a leaf blister insect. It feeds inside the leaf, and it's a very poor flyer. It attacks eucalypts. And when the eucalypt gets to about 6 meters, the height is high enough that the sawfly larvae is never a problem after that. So when it comes to something like leaf blister sawfly, again, someone asked treatment, something like a neonicotinoid or a pyrethroid. Those chemicals, pyrethroids are synthetic pyrethrum, and they're systemic. And one of the advantages of systemics is they go into the lamina, into the leaf, and we need that to happen to control things that are leaf feeding from the inside. So you can't get there without. That's been one of the big problems we've had with citrus leaf miner. It's a Lepidoptera. Very hard getting in and treating it without having issues with our citrus at the same time. So wasps or Hymenoptera are thin-waisted, sorry, I said thin-winged, thin-waisted insects in general, and they're mostly good guys. Bees are Hymenoptera, another group that are Hymenoptera ants, and there are a few ants that are problems. And this is one that I'll put a call out for you guys. I'm looking for some. This is a great ant. This is a muscle man ant. It's a carpenter ant or an ant that chews out the inside. I'm looking for a queen. So if anyone sees these inside a tree, I'd be interested in knowing more. So beautiful, fairly docile, wonderful ant. Ants in trees are generally not a problem. Ants are feeding on other things, but they sometimes can harvest. This is a native bee. They're a good bee. Most of our bees are great. So yeah, really don't have problems. These are muscleman ants again. Just gorgeous ant. Has anyone ever seen them inside trees apart from Peter? I know Peter's definitely seen them. No,
No.
they're around. They chew the inside out. They're very good. They farm scale insects in the inside. And they don't cause any big problems. They don't weaken the tree particularly or anything else. They're just there taking advantage. And in spite of the fact they've got mandibles that can tear wood out, I've never been bitten by one. So they're great guys. So look, if there's nothing else, can we go on to the next block? See you in a month's time. Please send in photographs of things that you want to have identified, because going through that process is important. When you do get photographs, please grab what it is and where it is, and give us that information as well. That'll help make it easier. Any other questions before we go? Any other requests before we get to the next block? I see a question, 2 questions in the chats. One's a thanks. So apparently there's an iPhone plant lookup. There's an there's a Plant Snap, and having gone and purchased Plant Snap's commercial side, I wouldn't go back to it for the free one from Google Lens. I'm absolutely hooked on Lens for its application in so many areas. Again, it's probably software that maybe they've acquired inappropriately. I have no idea, but it certainly works brilliantly, and they're constantly refining their algorithms. So it's definitely worthwhile playing with. Okay, guys, I'll see you in a month's time.
Thanks, Mark.
Yeah.
Thanks, Mark. Pete, all the best.
Thank you.
See you guys.